Okay, I'm all set up for my temperature test. So I have the computer, thermocouples. This is my speed control I just made. So I have the fan here. We just click this button that I got from a DVD player, and then it turns on. So it's going to cool the coils. Then we have the battery, the pump, and the motor, and here's the oil. So I'm going to take one temperature on the inlet, so the hot oil is going to come in here. We measure that temperature and it's going to pump through and come out here. And on this side, I'm going to put this piece. So this is actually the same piece I'm going to use on the solar test unit in the solar car. So there's a piece in there, 1/8 copper pipe that goes in, and that's going to sit here and it's going to measure the oil that's flowing through this piece. Now over here I have a copper wire and I have a thermocouple there. And I'm going to take this and I'm going to slide it all the way in. I'm going to support it with the wire to make sure it goes all the way to the bottom, so it's measuring the flow through the pipe. So there it is. There's a thermocouple wire, and the thermocouple goes down all the way in there, and then it's measuring about in the center there. So as the hot oil goes past this piece of copper, it's going to warm it up very quickly, and it'll give me an accurate temperature reading. And that's what I'm testing today. I'm going to compare the two different temperature readings, so the temperature of the oil in here and the temperature I'm reading of the oil flowing inside the pipe. So because the speed control got hot, I have this fan, so I just take this and I just click on the fan. It's just a computer fan, so it's blowing the air across the hot coils, and then I just turn it on. So now they're heating up, but it's blowing air. And it's pumping. Measuring the temperature, you can see this one is going up. This is the one that the oil flow, and this is at the bottom. This is the one in the pot. This one's going up, and you can see it's really pumping. And that's very hot oil, so this is pretty dangerous. So this is why I do a test like this. Now, when it's hot, I get a lot more oil leaking. It's that pivot there where the drive shaft is that causes a lot of problems. So this is a very old pump. It might be worth it for you to get a new version of this. Maybe it won't leak as much, but as I increase the temperature, this is only about 70 degrees. I'm going to go all the way to 200, so hopefully it doesn't get worse. So this is at about 100 degrees. I'm really worried about that leaking there in the back. So this here is speed 1, and this used to run much slower, so that now that the oil is hot, it's a lot less viscous. It's a lot easier to pump. And temperature's 123, and it's pumping right now. It's pumping oil over 100, so this would be enough to boil water in a heat exchanger. It's at 110 inside the pipe. Very hot. 112. I'm doing this test to check a couple things. Obviously the pump now, which I see is leaking quite a bit more at high temperature. Another thing is the solder, and I really shouldn't be using this solder. It gets soft at 180. It's pumping at 150 degrees Celsius. This is what I need for the solar thermal car. I need to circulate hot oil in order to boil water with the heat of the sun. It's running very well. So I have my speed here on number 1. Right now the temperature is 150 degrees in the pot, 141, 142 is being circulated. And that's at the very end. That's at the exit. So the oil that comes in is even hotter before it goes through. In the real solar thermal car, I'm going to insulate all these pipes as much as I can. In this test, I wanted to cool the oil a little bit as it circulated. I just bought this electrical element here. It was only about 100 pesos, which is maybe like $8. It has 5 different speeds, 5 different temperatures. So I'm just going to put this underneath the pot, and now I have my own test area. I don't have to move in and out of the kitchen, which is very difficult to move all this stuff. Also, this doesn't have any fire. I was always worried the propane somehow would catch some of the oil on fire and would cause a problem that way. This just has an element. So this is my new hot oil workstation. I have my computer there, the speed control, the battery's still charging. So the pump, and then I have this new hot plate, so I heat up the oil and pump it around. I have the Arduino and the thermocouples to check the temperature. So I can just run this whenever I want. I don't have to move it around. It's very difficult to move around to test at other places, so I'm going to do a lot of tests just the way it is, and it should work very well. It's over 100 now. The circulating oil is 110 degrees, and what's in the pot is 136. So I really don't want to get too close. But this is making a lot of noise now. I don't think it's lined up properly. Those gears are grinding and it's vibrating a lot. So I just finished the test, pumping the hot oil. So the blue is the temperature in the pot, the oil that's sitting there, so it heats up, and then this is the first time I turn on the pump. And this is the temperature, the red one is the temperature at the exit of the pump. So the oil goes through the pump and then heats up the thermocouple. So this is really what I wanted to see, is the reaction time here. So it heats up very quickly every time. These are all the times I turn on the pump. The pot got up to about 155 degrees Celsius, and the hottest temperature through the exit of the pump was about 130 degrees Celsius. But it cools down as it goes through the pipe, so what's going through the pump is probably even hotter. And there's a little bit of a gap here, and that's just the oil cooling down as it goes through the pump and the copper pipes. Now I just enlarged, I just took one section, so this is where I turned on the pump, and it took about 30 seconds to increase 40 degrees, and the pot temperature decreases as I circulate and cool it. So that's a really good amount of temperature change in a short period of time. So this proves that the pump is working well. The temperature, I can read thermocouple temperature and record it with the Arduino. So now I think I'm about ready to test in my solar thermal test unit.